Look up on a clear day, and the sky looks completely empty. But right now, you are walking around at the very bottom of a massive, invisible ocean of gas. And while it feels limitless from down here, it is actually incredibly fragile. If you look at Earth from space, that life-saving ocean is just a glowing, paper-thin band clinging to the rock. To understand our world, you have to be able to navigate this band. But textbooks usually treat it as a dry list of permanent gases and a stack of zones with abstract names like the mesosphere. If you have ever tried to memorize these layers, you know how quickly the names and numbers blur together into a soup of jargon. We can clear that fog. By the end of this video, the sky won't be a list of facts anymore. It will be a mental landscape you can visualize as clearly as your own neighborhood. Take a deep breath. What exactly did you just pull into your lungs? You know oxygen is in there, and probably nitrogen, but the chemistry of our air involves 9 specific permanent gases. To keep these 9 gases organized, picture a specific person in a busy kitchen. Imagine a naughty old aunt who cooks nice K, hot, extra hot. Let's see how that maps to the air. This pie chart maps the atmosphere. Nitrogen, naughty, is 78%. Oxygen, old, is 21%. Ant, argon, is 1%. Zooming in, cooks is carbon dioxide. Nice is neon. K is krypton. Finally, hot is a helium balloon. Extra is xenon. And hot is a hydrogen star. By linking these chemical names to a vivid, tangible image, the sequence becomes intuitive. You aren't just reciting a list, you're following a recipe. Once you have the ingredients, you have to look at how they are stacked. From the ground up, we have the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. You can remember them as tall students make terrible excuses. It seems natural to assume that as you go higher toward the freezing vacuum of space, the air just gets colder and colder. But that isn't what happens. The temperature actually bounces back and forth in a giant zigzag. Let's plot this on a graph. Starting at the ground in the troposphere, the line slants to the left, getting colder as we go up. This is because the Earth's surface acts like a space heater, absorbing solar energy. As you move higher, you're simply moving away from the heat source. But then the line hits the stratosphere. This satellite data shows why. The ozone layer. Ozone absorbs incoming ultraviolet rays from the sun. Because it is actively catching all that energy, the stratosphere actually warms back up. Our graph takes a sharp turn to the right. Once we leave that ozone behind, we enter the mesosphere. The air here is thin and incredibly cold, but there is still enough of it to create friction when space rocks hit it, giving us shooting stars. Without the ozone to catch heat, the temperature plunges to -100 degrees Celsius. Our graph line dives back to the left, hitting the absolute coldest point in our atmosphere. Above that is the thermosphere. This is the orbital home of the International Space Station, the first layer to face the sun's raw, unfiltered power. Because this layer absorbs intense solar radiation, the temperature skyrockets. The graph line shoots all the way to the right and completes a massive Z before finally merging with the emptiness of the exosphere. This zigzag gives us a logical map. By linking each turn to a physical reason, the warm ground, ozone, or direct sun, the invisible layers make sense. When you put these images together, you have a complete mental model. You have the kitchen at the bottom for the gases, and the Z-graph rising above it to show exactly how the layers behave. Try it yourself right now. Pause for a second, and see if you can visualize the 9 gases and the 5 layers from the ground up. If you could see that kitchen and that zigzagging line, the geography of the sky is now part of your intuition. This isn't just a list of facts. It is a dynamic, layered shield. It intercepts radiation, burns up space rocks, and keeps our planet at the perfect temperature for life. Understanding this structure changes the way you look at the world. The next time you look up on a clear day, the sky won't look empty. You'll see the neighborhoods of the atmosphere